Good morning. Welcome to the class ECE 210. Now I'm recording the lecture of this Wednesday, that is November 22, tomorrow. Tomorrow's class, alright. And actually this will be the last lecture of the whole semester with new material. And in the end of this class, in this lecture, I will give a short review for the final exam. And then next week, I will schedule some Zoom meeting. So if you have any question during your review for the final, we can discuss. And for the detail about the final exam, I will give you an announcement posted in the Blackboard. Okay. Now go to today's what we will do. Okay, the last chapter, last assignment is here, chapter 12. S-domain circuit element models we have studied last time. Now we consider the S-domain circuit analysis. Right. Slow. Quite slow. Sorry. The internet. Okay. S-domain circuit analysis. Why is it writing this way? Must be. Oh, it's displayed. Okay. The S-domain circuit analysis technique, we have these 4 steps. The first step, transfer the circuit from the time domain to the S domain, as we did last time, right? Remember? And then apply the KVL or KCL and other circuit tools to obtain the explicit expression to the voltage or current of interest. Just write equations. Actually, we will find the equations. And if need a partial, anyway, you need to solve those equations, and maybe you need a partial fraction. And then actually this is the inverse Laplace transform. We need to go back, transfer back to the time domain. So we have 4 steps. Okay, now all the knowledge you already have. So here just we practice on some examples. The first one, we have circuit look like this. We have circuit with current source and 3 devices connected parallelly: a resistor, an inductor, a capacitor. Alright, and the input side, the signal is Is of t. It's a current, right? It's a current source. So it's 0, then 6 ampere, then 0 again. You can think here we have kind of supply, then stop. In the beginning, no supply, then you have the power and stop the power, right? So you have a Is looks like this. Then we want to determine what? Let me see. Given R, L, and C, determine the IC. Okay, we determine this one. IC, right? IC of t. We want to determine IC of t. Now we how to do it? First step, we draw the circuit again, and just to change, just change this I, L, I, R, I, C, these three current in time domain to S domain. So you just change this lowercase I to be capital I. That's it, right? That's it. And here's Is is capital Is, right? All these are the S domain, capital letter. And then each part, here we remember R will go to still R, L will go to SL, and 1 will go to SC. Remember, we can look back. If you cannot remember, we can go back to we can go back to the this section. Eh? Nothing happened. Eh? I clicked it, nothing happened. Oh, what's wrong? I should wait. Wait so long? Okay, just okay. Anyway, you should remember, right? Okay, then we have this part circuit. Now we it's the internet problem. Yeah, this one. You see, we have this table, right? We have this table. R is still R, and L will be SL. SL with different initial value. But in our example right now, the initial value is just 0. So we do not need these two powers. Alright. And here's C will be 1 over SC. Yeah, similar. 0 initial, so we do not need this for initials. Right? Yeah. Okay. And then let's go back. Oh, we still need some time. Okay, it's a problem. It's internet problem maybe. All right. Actually, here the graph gives us the final answer. We will see the answer later. Now, how to solve it? It's explained this. Okay, here we can have the equation. They explain something. Yeah, we start from equation. Look at here. Okay, let me copy the circuit in S domain in my paper, and then let me explain here. Okay, and let me copy it. We have 3 parts. This is R, this is SL, this is 1 over SC, and we have IR, IL, IC, and here's IS, and they put the voltage. Oh, the voltage here is V, and this side is ground. Okay, now let's go to camera. Oh, this is really just slow. Maybe some virus in my computer. Yesterday is still fine, right? No, this camera. Document camera. Oh. Yeah, something wrong. I don't know. Maybe some virus. Yesterday is fine, right? Remember last lecture when I record, it runs smoothly. Now it's just always really slow. Yeah, I already opened these 1, 2, 3 windows. One is a camera of me, you can see me. The other is oh, it disappeared. I need to start again. Terrible. Okay. Alright. So we have the circuit, right? We have the circuit. Now we try to write the equation, and we can work in as same as in the textbook. We use KCL. So here we have 4 current. One is IS, is given one, and IR, IL, and IC, they are unknowns. And the relation is IS will equal to IR plus IL plus IC, right? It's IS coming up and separate to 3 directions, so like this. And each IS is given, and okay, I put it IR IR, I put the voltage here, then IR will be V over R. And IL, this one will be V over SL. And IC will be V over 1 over SC. Yeah, you can call all these three parameters R, SL, and 1 over SC as a impedance, right? And they are working similar as the Ohm's law. Okay. Now the what is V? Okay, if I write in this way, this is given. Okay, here's just one unknown, right? Just one unknown. V is unknown, so we can have V equal to IS over 1 over R plus 1 over SL plus 1 over SC. Actually, this one can be written just as SC, right? SC. Well, this is not final answer. We want to find IC, right? IC will be V over 1 over SC, right? Yes, V over this. You consider this is R, V over I, like Ohm's law. Then this one where V is this. Okay, so I write this. Yeah, one more step. I can write this as I times SC. And here is 1 over SC times SC. Then this can be cancelled, right? So it is V times SC. And then V is this one. So it is IS times SC over 1 over R plus 1 over SL plus, this is just SC, right? I write this in this way. Then this is a fraction of fractions. Denominator we have more fractions. This usually we do not like this, but can we make some simplify? Right? Times. When you change the fraction, you have some laws like move some part from denominator to somewhere else. And how to do it? There are several laws. Sometimes they make things complex and confused. You just remember one thing: you times or divided something, same thing in both numerator and denominator. You can keep the fraction, nothing change, right? Okay, so now I want to cancel this R and SL in these two denominators. So I times RLS times RLS. So this is same thing, right? This same thing. You can cancel this, you go back. Now I do not cancel it. I times them inside. So I have numerator is IS times CRLS squared. And the denominator, I times RLS in this one, I have LS. I times here, I get R. I times this one to here, I get RCLS squared. Alright, we have IC. I see this one. Let me see. Actually, this is not final answer, right? You can do more simplify here, or just here what is IS. You plug in IS, then do more simplify. You can see here. What is IS? V equal to this one, so you can have V. V is S squared over these. Yeah, okay, so they do simplify. They want the coefficient before S squared is 1. Alright, we keep this in mind, and we will follow this when we work on it. And also I want to know what is IC. Now what is IS, right? What is IS? Now IS is this one. It's this rectangle coming up and going down, right? So it is up by 6. So it's a 6 of unit step and minus 6, the same unit step but happen at time equal to 1. So IST, this one. Then you just check the table. You can find these two terms from the table directly. So you copy this here. You can have capital I of S, right? You go to the S domain. The lowercase I tend to be capital I. Then 6u of t tend to be 6 times 1 over S. And 6 times these u of t minus 1 tend to be 6 times these e to the negative ts over s. Now capital T is 1, right? Capital T is 1. T shifted by 1. Capital T is 1. So e to the negative s. E to the negative s over s times 6. Oh, so this is is. This is is. Okay, let me copy what is is here. In my paper, is equal to 6 over s minus 6 over s e to the negative s. Okay, so you plug in is into this part, you can find an answer. Actually here, if you read these, at least for me, I prefer calculate by myself, because when you do simplify, your idea might be different with others. Actually, everyone will think in different ways. Here and here will be different. So you follow your way to think about it. Yeah, just make sure every step you are correct. Then finally you will have same answer, right? So okay, so now I have is is this one, and let's go back to my paper. This one, oh, it's this one. I already have IC, right? I see this. It is this one, and is is this one. So plugging is here. Then I have IC equal to is. I put in the front is 6 over s minus 6 over s e to the negative s times. Here's a CRL s squared over. Okay, I put these three terms in order with power of s. So this s squared in the first. So RCL s squared plus LS plus R. Okay, we have this one, e to the negative s. This one will tell you the u of t, or some others happen at we have something happen. You can check. Do we have the table? Okay, we do simplify later. After we do the simplify, I have 6 over s times this, right? 6 over s. So numerator is 6 times. I put the RCL. Yeah, use the same order. RCL, right? Same thing. And s squared divided by 1 of s. I have s. And then RCL any change? Yeah, this s cancel with this s squared, so we just keep RCL s squared. Denominator nothing change, right? LS plus R. This is first term. Second term, we still need the same 6 over s times this part, and then times e to negative s. So it's the same with these, just we have one more thing. 6 RCLS over RCLS squared plus LS plus R times e to the negative s. So we have these two parts. And now you can use the formula. You can also plug in the values. I prefer plugging the values, maybe simpler. Go to here. What is the values here? R. Is here. R equal to 125 ohm. L is 0.1 Henry, and C is 4 millifarad. Okay. Now go back. Now we have several parameters. Yeah, if I cancel these, this will be s squared, but this one will be some dividing. Okay, just put numbers. Then RCL equal to, I need a calculator. Okay. This one we have 125, this R, times C, it is 4, times L is 0.1. I get 50. But this 50, we have a milli, for the capacitor we have a milli here. We have milli here. So we need to divide by 1,000, I get 0.05. L just L, R just R. And so after these, we have IC or equal to, okay, I can put these two together, right? And this is 1 minus e to negative s times, yeah, this is similar. This is 6 times these, I get 0.3 s. And here's a 0.05 s squared plus L is 0.1 s plus R is 125. I get this. Alright. Now we can change it to be 1. So I times 20, right? Times 20. Times 20 on both numerator and denominator, I can make this to be 1. So I get 1 minus e to negative s times, this is times 20, I get 6 s. And here's s squared plus times 20, I get 2 s. And times 20, this is 2500. Oh, it's a large number. Okay. Now we need to do the inverse Laplace transform. We want to find the inverse Laplace transform of IC. We can check the table. Can we find this one directly from the table? If we can, then just use the table. If it is not, we will use partial fraction to separate it as some simpler parts, so we can use the table. Now go to the table. Table is in chapter 12. This is Peirce, Laplace transform Peirce. We have numerator is s, denominator is, okay, we do not have directly that one, but we have these 13 and 14. You see, 13 and 14. 13 and 14. And 14, right? 13 and 14. So we need to use 13 and 14 because our numerator just contains s, no a. So you need to use another one, a. So I write in this way. I write it in this way. Okay, let me copy this in my paper. Here I have e to the negative at sine of omega t u of t according to s plus a squared plus omega squared in denominator, and the numerator is omega. And e to negative at cosine omega t times u of t according to s plus a and s plus a squared plus omega squared. You see? Alright, here you see, if you have your table in a paper in your hand, now you will be quite convenient, right? You don't need a, you can look at both. You can look at the screen also with the table. Now I look at table, I cannot go back to my paper. Yeah. Okay, let's go back to my paper. Yeah. Oh, I can make this small, large. Anyway, need to change. Okay, so we will try to write our fraction in terms of these two. You can see, okay, IC equal to 1 minus e to negative s. I keep these, and this part denominator I can write as s plus 1 squared plus 2499, right? A plus 1 here, minus 1 here. This is a s plus 1 squared, as same as plus a squared. So that means a is 1, and omega is the square root of 2499. It's almost 50, but it's a little bit smaller than 50. And the numerator, we have two kind of numerator, even s plus a or omega. So here's a 6 of s plus a, right? We want s plus a, so this s plus a. But here exactly it is no a here. So you add a, you need to minus a, like this. Then they are same thing, right? From here to here, see, from here to here, they are equal. All right, now I separate 1 minus e to negative s. I keep it, and this part I separate it as two parts. One is s plus 1 squared plus 2499. Here's a 6 of s plus a, and this one is minus 6 s plus 1 squared plus 2499, and omega this were equal to omega is a square root of 2499. This is 49.98999. Okay, just 99 is fine. Yeah, this, yeah. I put this 9 to here. Yeah. 49.99, almost 50. Okay. Then here I want, this is omega, but now this is 6. So how to do it? I times 49.99. This is omega, and divided 49.99. So I have an omega here, right? This is omega, and this part is s plus a. Okay, one more step. This is 6 times s plus 1 squared plus 2499, and here's minus 6 over 49.99 times omega. Yeah, I just put omega. This is s plus 1 squared plus omega squared. Alright, so now we have two parts. One part is 1 times all of these. One is e to the negative s times all of these. 1 time all of these, we can use table directly. Right? We can use table directly. We can use these two. Use these two. Use these two. Go back to, we can find these two. And e to the negative s. What is e to the negative s? We can check. We have another table. We have two tables. That table will show us if I times e to the negative s here, what will happen? It's a Laplace transform property. It's just, I should have clicked it earlier. I click it. Click again. Oh my god. Yeah, some virus, I think. Why is it so slow? Yesterday is fine, right? Yesterday I recorded the lecture. Everything runs smoothly. Okay. The property, they have table. Actually, we just go directly to table. Okay, here. Which one we have e to the negative sum s? Here, you see? E to the negative ts times fs. Then go back, will be this one. So this capital F go to lowercase f, and times e to negative ts, you just shift on it. Okay, let me copy this. I copy this. It is ft minus capital T times u of t minus t, according to e to the negative ts times f of s. Okay. Now go back to our work. I already have this, right? So we times these on fs. So this one is fs. This is fs. This is fs. You times these on fs, it is just ft minus capital T times u of t minus t. So first of all, you need to find what is ft. Ft is inverse Laplace transform of fs. So fs, you just start from fs, find ft. Actually, this is what we should do, right? 1 times this, go to the time domain. This is, I do this. This is ft for t. Ft, it is 6 times this. So it is 6 times this part in time domain, we copy it here, right? This one go to here. So it is e to the negative at. Now a is 1, so it's negative t. The cosine of omega t. Omega is 2499. 2499. No doubt here. 2499 square root is this one 49. 49.99. 49.99 t. And then u of t. This is this part. And second part is this one is minus 6 over, okay, I gave the value 6 over, this one is what? 6 divided by I'm sorry, I typed something wrong. 6 divided by 49.99 is 0.12. 0.12. Not this. This one. 112. And something. Yeah, just 0.12. It's 0.12 times this part. This part go to time domain. You see, this one go to time domain, this one. So it's e to the negative at, a is 1, and sine of omega t, then u of t. Okay, this is f of t. This is f of t. Right? 1 times this capital F. Now go to time domain. Yeah, here's not equal. Here's by inverse Laplace transform. So go to time domain. They are different, right? This is in S, this is in T. They are different, but it's related by inverse Laplace transform. Okay, I have f of t. F of t. The minus e to negative s times capital F. Now capital F we obtain the lowercase f we have, right? So lowercase f minus t times u of t. So okay, so we will change all the t by t minus capital T. That is t minus 1. Okay, so this is 6 e to the negative t minus 1. And cosine of 49.99 t minus 1. Replace all the t by t minus 1. And the u of t minus 1. Here you need to times one more t, u of t minus 1. But we know this is either 1 or 0, right? U of something, this is a unit step function, so its value will be 1 for positive t or 0 for negative t. So its value will be 0 or 1. So u times u is still u. U square t, it is just u because either 0 or 1. Square is still same thing, right? 0 square is 0, 1 square is 1, so it's the same thing. So I have 2 of u of t minus 1. Here I only need 1. Okay, the next minus 0.12. This is coefficient, right? Times e to the negative t minus 1. And the sine of 49.99 t minus 1. And u of t minus 1. Let me see. This one go to this one, and the time this one get to this one. Oh, here's a minus. Here's a minus. So it is like this. Minus of all of these. If you remove, here will be plus. So this will be the final answer. And can we do some simplify? Yeah, this one both contain 49 cosine, so I can put these 2 together, and the coefficient different in the coefficient. And this one I move them different in coefficient. Okay. I move this one out. I have cosine. Move this in the back. Then I have this one, and yeah, I put these 2 together. I put the e to the. I put these 2. Put the ratio. We have different way to simplify, but even I simplify, there's still, I think, still 4 terms, right? Still 4 terms. These 2 same, but these 2 different. These 2 same, these 2 same, these 2 different. Yeah, I can put this 6 times e to the negative t cosine of 49.99 t times, this is u of t, right? This one is u of t. And this one is minus, here we move e to the negative t here, right? We move this to here. Then this one, I have another e, just e, right? E, this is negative, so just e times e. I leave the e here. E and the u of t minus 1. Yeah, this that makes sense. Okay, anyway, a little bit simpler. And these 2, I also do same thing. Minus 0.12 times e to negative t, and then the cosine, sine of 49. Oh, I'm sorry, I can't. These 2 are different. Here's a minus 1. No. So totally, I cannot move these together. Okay, I just keep like this. Yeah, this is shift 1. Just 4 terms. Alright, let me see. The textbook. What is we're in the different section. This 12. We are here. S domain analysis. I'm sorry. Something wrong in my computer. So slow. They do it in different way. They gave angle. Okay, the answer is this one. They work in different way. Let me compare their result with mine. 6 e to negative t cosine. Okay, they just use 50 as omega, because omega's exact value is 49.99. So you can think this is just 50. So 50t and plus a shift times u of t. Oh, they combine them together. So this is shorter. Yeah, this is shorter. They need to combine these, then they need to use a complex calculation. Let me see. Yeah, they use a complex calculation. Now you can avoid to use that complex calculation. Then you can have. Then there will be my answer. Can we change from my answer to their complex way? Yes, I can. Yeah, okay. So you can have this final answer. You can have this final answer. You can also have my final answer, but both will be same thing. Those will be same thing. Have time? Yeah, I have 10 more minutes. We can do that. Yeah. Okay, let's go back to my work. So my answer is here, right? My answer is here. Now they work like this. They combine these two terms both with u of t. Here's a t. Here's a t, right? They're together. So I can have this is IC t equal to, I put these two together, this will be e to the negative t. I put the e to negative in the front, and here's 6 times cosine. Okay, I just use 50t as we did in the textbook, as they did in the textbook, and minus 0.12 e to negative in the front. So here's a sine of 50t and the u of t. These two terms. And this second one, minus e to the negative t minus 1 and 6 cosine 50 t minus 1 and minus 0.12. This one moved to the front. This is a sine of 50t minus 1. And then both contain u of t minus 1. Okay, separated at these two parts. Then about this one, I have 6 times cosine and the negative 0.12 with a sine. Here's a 6 with cosine and negative 1 point with a 1.2 with a sine. This is cosine, right? And we can have this one like 6 cosine. I say this is at, some a, whatever, minus 0.12 sine of a. A is either 50t or 50t minus 1. This one I can write in this way. I have 6 squared plus 0.12 squared and square root times, here is a 6 over 6 squared plus 0.12 squared times cosine a minus 0.12 6 squared plus 0.12 sine a. You can write this. Then this one can be a cosine of some angle. You know, this will be cosine of something. This is sine of something. This is alpha. Cosine a minus sine alpha. Sine a. Where alpha is like this. Here's a 6 and here's a 0.12. This angle is alpha. This angle is alpha. You see? Right? The length from here to here, that is 6 squared plus 0.12 square root. And 6 over these is cosine. And 0.12 over this is a sine. This should be, okay, this alpha should be, alpha is a cosine of 6 over 6 squared plus 0.12. Yeah, we can have this. It should be this one. Okay, I don't want to do it. Yeah, just keep it. Alright. So this will be this one. 1 dot 15 degrees. So it should be 1 dot 115 degree. This is alpha. And this one will equal to cosine of a plus alpha. Yeah, you have formula, right? Cosine minus sine, got cosine a plus alpha. Cosine a plus alpha. Yeah, it's weird. I don't know, something wrong. Anyway, so the final answer will be same. By this way, we can have this e negative t times these square root of 6 square plus 0.12 square. This is close to just 6. And e to negative t, then cosine. Yeah, it's tough. Yeah, sorry. Oh, okay, I don't do it. Do it. It is so slow. I'm sorry. Go back. Don't try to do it. Yeah, I have to be close there. Yeah, I'm sorry. Okay, anyway. So here, this is 6 times e to negative t cosine the angle plus 1.150 degree. This 1.150 degree will be our cosine of our value. Let me copy it here and I got this. Right, this one. This should be so. This one, this angle should be 1.15 degree, and this is a cosine that alpha times cosine A minus sine alpha sine A. It will be just cosine A plus alpha, and this value 6 square plus 0.12 square take square root is almost 6. So we can just use 6, this part as a 6, this number as 6. So it is this is a 6. Then times this is a cosine of A is the first one is A is omega 6. A is a cosine 50t, and plus alpha is 1.150 degree. So this part will be this one. And the second part is similar, minus e to negative t, 1 minus t, and 6 times cosine. Now this is a 50 t minus 50, right? Minus 50 plus 1.1 degree, like this. Yeah. And of course we still need a u of t minus 1. Compare with the answer here. Yeah, t minus 1 plus this degree. Okay, here you should do not merge this 50 and 1.150 together, because this 50 is in readers and this 1.15 is in degrees. If you want to combine these two together, you need to change them. Usually you change this to be readers. Okay. Yeah, you can just keep the answer like this. Well, this example looks complex. The final answer is complex, and we need some calculation according to the triangular functions to get or some complex number calculation. You see here, they do some complex number. In the textbook, they work with the complex numbers, and in my way to work with avoid the complex number, but I need, if I want to find the same answer with these, I need something of the triangular functions. So this is somehow complex. And in the final exam, as I told, I will give you 2 problems about the last part. I will not give you so complex things. You just remember these 4 steps. You should know how to work in these 4 steps, right? We have these 4 steps. You write the circuit in the S domain and give the equation in the same way as in the normal way in time domain, but in the S domain. This is step 2. Give the equations, and then try to solve it. Maybe you need partial fractions, and finally use the inverse Laplace transform to find the answer in time domain. You know these 4 steps. Just follow these 4 steps. You will be fine. And this example is the function. Okay, parallel connected. It's complex. Anyway, I will give a simpler one, like only contain now here's parallel of 3 terms. Maybe I give you a circuit with series with two element, not 3 element, or I think series will make it simpler. Yeah, and other examples. Yeah, you can try to. Yeah, this one should be similar. Oh, this is still 3. It's still 3. Let me see. The equation will be. Yeah, they also need a complex. You use complex way to calculate. You can also follow me in the real domain to do it. Yeah, if you have 3 part, but if you have 2 part, not 3 part, 2 part, you work in the same way, but all the calculation will be similar. Here, okay, so all of them complex one with 3. This is also 3 term, right? 3, 2 resistor and 1 arrow. Oh, this might be similar. This might be similar because you can do some. Is similar? Not exactly similar. Yeah. But do we have more practice? These are the examples. Yeah, you have some practice. Okay, like this practice, you only contain 2 parts. You can try these. It will be similar, right? Similar, same way as we did in the example. Okay, now almost time. Yeah, it's part time. I said I will give a short review, but it seems I do not have time. So next time, okay. Next Monday's class, I give the short review. Then the office hour I will put on Wednesday. Office hour and the class discussion I will put on Wednesday and Friday. Friday, suppose we do not have class, right? But I suppose you will not have class 2 at Friday, not have other class. So that time, Friday 2 o'clock and Friday 4 o'clock, these 2 times you should be free, right? You have no more other class. So I use that tool for our discussion about the problems, kind of office hour. All right. So next Monday is a review, and Wednesday and Friday is a discussion. Okay. Okay, that's all for today. See you next time. Sorry, today is the computer. I don't know what's wrong, so it's slow. Hopefully next time will be fine. Okay, bye bye.